Good evening, this is a breaking news report. Lately, statistics show that the water crisis is threatening many developing countries. 783 million people do not have access to clean and safe water worldwide. 1 in 9 people worldwide do not have access to safe and clean drinking water. Today, we will take Kenya as an example, as one of the developing countries with clean water sources scarcity problem. According to the data of the World Development Index, only 63.2% of the population in Kenya have the access to improved water source. Almost half of the rural population do not have the access. It shows the seriousness of water problem in Kenya. For the main sources of pollutants in the water source of Kenya are pesticides, sewages, and nutrition. Economy of many countries in Africa is based on agriculture. Pesticides are used in farming. The runoff of soil with pesticides contaminate waters. Secondly, the sewage systems in Kenya are not yet well developed, which causes the pollution of underground water. The runoff from farmlands and the mining of mineral nearby also cause the rise of pH levels and mineral levels in the water sources, which makes them unsuitable to use. It also results in the reproduction of pathogens and bacteria in water. For the effects of the water problem, the drinking of contaminated water causes diseases such as cholera. In developing countries, up to 80% of illness are linked to poor water and sanitation conditions. Nearly 1 out of every 5 deaths under the age of 5 worldwide is due to water-related diseases. For the impact of water pollution problem, from the education aspect, many females have to give up education in order to take water from the water sources that is 4 miles away from home. Almost 2/3 of the household rely on women to get the family's water. Students also lose many learning opportunities due to the disease caused by the dirty water. 443 million school days are lost each year due to water-related diseases. Polluted water also harms agriculture. Water with high mineral contents is not suitable for watering crops. The above problems caused by water pollution also harms economic development and sustainability of Kenya. To solve the water pollution problems, there are some new technology in portable water purifier. Let's have a look at the situation in Kenya.
Stop, sir! I'm from Leicester SA, and based on our observations, the water is definitely not safe for drinking here. So I bought you this, one of our life straws. Please don't look suspicious. See, the whole filtration process does not involve any chemicals. Instead, there are hollow fibers that can trap things that are larger than 0.2 microns. That is basically all sorts of bacteria like E. coli and protozoa like Georgia. And it is super convenient too, it is only weighs 57 grams and you can take it everywhere. Whenever you are thirsty, you can just take it out from your backpack and even from your pocket. And you can take a sip from rivers and lakes without hesitation.
Oh wait, no. What is the inside? How could I know what I'm drinking? It's opaque and I don't know how clean the water is. You only said that it could remove bacteria, but how about virus, heavy metals, and chemicals? Will I be die when I drink too much from the straw? Don't you think that it's safe for me to drink the water when it's only bacteria free? Also, I cannot use the filter for my cooking. Shouldn't I have to spit my water from my mouth for cooking? No way. Condiments and my children, they don't know how to drink the water from the straw. Don't you think that they will die when they're thirsty? The most important is, my house is far away from the water. It's useless. Damn it.
The life straw doesn't seem to work. Why not offer them drinkable bowl?
Yes, the drinkable book is developed by Dr. Teresa D, the co-founder and chief scientist of Flow Water. The pages of the book are made of silver nanoparticles which can kill 99.9% of waterborne disease like cholera and E. coli of highly contaminated water. Silver nanoparticles are effective antimicrobial as they bind to tissue protein and bring structural changes in bacteria, cell wall, and nuclear membrane, leading to self-destruction and death. Most importantly, they are non-toxic material and won't cause antibiotic resistance to bacteria.
That's right, and also, one page can purify up to 100 liters of water. One book can fulfill one person's water need for 4 years. Also, the main material, silver nanoparticles, is not difficult to get in real life. We can buy 1 kilogram of silver iron liquid for only 220 RMB on Alibaba. Due to its simple production, manufacturing one book with 100 pages by hand only costs approximately $10. With high efficiency and low cost of production, the drinkable book can be widely used because the book is both affordable and beneficial for people in Kenya.
Wow, it sounds better. We still have room for improvement. Would they?
The potable water purifiers nowadays mainly kills bacteria but not able to remove inorganic matters and chemicals like metal ions and pesticides. The new design aims to remove both organic and inorganic matters and at the same time provide a technology that even citizens in developing countries can afford.
This is the overview of our proposed design. Now let's take a closer look at it. It consists of a handle-off spinner, a rough filter, silver nanoparticle filter, as well as activated carbon filter.
Raw filters are used for the removal of particles of coarse size. The water that we need to purify may contain a lot of large particles, for example sand, which greatly affect the effectiveness of the filter if it blocks the silver nitrate filter. The installations of raw filters, which is 0.8 mm in our design, is to prevent the large particle blocking the silver nitrate filter. Another important point in our design is that the container is transparent. From the above, Kenyan is curious about what he is drinking and doubt the effectiveness of live straw. Transparencies of the filter allow Kenyans to observe what they are drinking, that is, whether the colors of the water looks clean and drinkable, which can give Kenyans more faith on the filters, compared to live straw, which is not transparent. Our design ensures that people can see the water that has passed through the filter inside the container. Not only does the design build up confidence in drinking the water which is filtered by our design and prevent the blockage of the silver nitrate filter, it is portable and easy to carry from one place to another place. Although the live straw and drinkable book can be carried around, but they cannot store water for further usage. The size of our design is like 600 mm bottle that we often use in daily life, which is easy to carry around and drink water anytime, anywhere. Compared to live straw and drinkable book, the water can be stored up in the new design, and the Kenyans can drink the water when they are thirsty.
Due to the low cost and high efficiency, silver nanoparticle filter paper will be added in the carbon spinner as the main tool to deal with the problem of bacteria in the highly contaminated water. The production of those papers is simple. To make the paper, we need to soak the normal filter paper in a bath of silver ions and a chemical reduction agent. Then heat the paper at about 200 degrees Fahrenheit for a few minutes, and then the paper gets rinsed and dried when it is full of silver nanoparticles. When the contaminated go through the filter paper, the silver ions in the paper will be absorbed by germs and then kill them, and thus effectively remove the bacteria from water. As for the materials, silver nanoparticle solution called Nano AG1000, which is sold for 175 RMB per kilogram on Alibaba, is chosen since it is suitable for medical use, which means it does no harm to human health. And the level of silver of the solution is 1 gram per liter. And according to the experiment of comparing the bacterial removal by a number of low-cost filter materials quoted with silver nanoparticle, the optimal filter loading is 0.1 mg per mole. And the calculation is shown below. In 1 kg silver nanoparticle solution, the mass of diluted solution is 206.57 kg. And we assume 1 square meter of normal silver filter paper absorbs as much water as 1 square meter of paper towel does. The total area of filter paper is 678 square meter, which equals to the area of 10,870 pieces of A4 papers. And then we chose a kind of filter paper called qualitative grade rectangular filter sheets, which is sold 6.7 RMB per square meter on Alibaba. And the cost of each piece of silver nanoparticle filter paper is only around 0.434 RMB, which is affordable.
Granular activated carbon (GAC) is a common household filter used to process absorptions to remove the pollutants, such as natural organic compounds, odors, and synthetic organic chemicals from the polluted waters. To know the mechanism of GAC, we have to know about the properties of GAC first. GAC is a highly porous material that has a large surface such that 1 gram of GAC has greater than 1,000 meters square of surface area. Also, it has a high ability to absorb organic chemicals with molecular mass below 1,000. What's more, GAC is a carbon-based compound that are typically hydrophobic and non-polar that allowed to process absorptions within the device. For the mechanism of GAC, absorptions take place because all molecules exert force adhere to each other. The attractive forces between the carbon surface and the contaminants, which are non-polar, are stronger than the force keeping the contaminants dissolved in water, which is in polar. The absorptive forces are weak and cannot occur unless the organic molecules are close to the carbon surface. The large surface area of activated carbon is due to its particle size and pore configurations, allowed for the absorptions to take place. Moreover, we have to note that the absorptions of contaminants with activated carbon is high at low concentration than the higher concentrations, and the lower flow rate and longer contact time in the device will have a high efficiency of removing contaminant too. Finally, for the calculation part, we have to know the volume of GAC required in the device. By calculation, we know that the optimal mass of GAC is around 0.42 kilograms and the volume is around 285 cm square. Thus, we know we could remove around 42 grams of organic compounds in the device. And for the cost, from our web search in Taobao, just like the eBay in China, we know that 1 kilograms of GAC is around 30.5 Hong Kong dollars. As we need 0.4 kilograms of GAC per one use. The cost is around 30.5 multiplied 0.4, which is around $7 per use, which is a relatively cheap material to use to filter water.
As mentioned, activated carbon is added into the new product. It contains lots of tiny holes to absorb particles, which means that by passing through more holes, the more impurities could be absorbed and the more sufficient the purifier would be. By inspiration of centrifuges, we decided to make the filter into a spinner. The reason is that polluted water usually contains pesticides, heavy metals, and other particles which have larger molecular mass than water molecules. And when fluid is in a centrifuge, the ones with larger molar mass would experience a larger influence from the spin because of inertia, and they would move outwards and interact with the carbon filter fully at relatively high flowing speed, which allows them to go through more area of the carbon filter. That's why this proposed product is more efficient than the existing ones. To make the filter spin, we utilize the structure of a salad spinner. There's a handle on the top. When we spin the handle, the filter inside would spin as well. According to lever, once you spin the handle, the filter would spin at a faster rate.
In conclusion, when comparing the new design to the former designs, the filtration of the new portable purifier is more thorough than live straw and drinkable book. The new design is able to filter heavy metal ions and chemicals, which the former designs cannot remove. The quality of purified water is raised. On top of that, The new design is transparent, which will make consumers have more confidence to the quality of the purified water as they can see the process of purification. The new design is also more convenient as it can store purified water, so that the consumer need not consume all purified water at once. The above shows that the effectiveness, appearance, and portability of the new design is better than the previous designs. That's all for tonight. Good night.